Hi everyone, it's June week 2. We have some demos from the community team. Let's get started.
Start with pulling the data. So I just have a table right here where it stores all of the messages that I pulled. And then I extract the date time of all of those messages. And you can see that in this table right here. So I have message instances, and then I have the date that it was sent. So the next thing that I'm going to do is I want to visualize data by the minute. So I am going to use lower bin to create a new column, which just basically floors all of these timestamps to the minute. So I end up with a table that looks like this. As you can see, everything is rounded to the minute. And then the next thing I'm going to do is I want to do a count by the minute of my messages that I sent. So next I create a new table with a new column that is going to have the count by the date sent minute column that I just created. And now I have a table containing my X values and Y values that I want to plot, with X being the date time and Y being this count. And all I need to do is, whoops, that was the wrong table. All I need to do is just create a simple plot. And now I have a nice visualization of the messages that I have sent over a certain period of time.
All right. So today I have for you a demonstration of the new Go API that should be finished by the end of the month. It's has all the features that the Python API has, plus a little bit extra at the moment. And the demonstration I have here is of a live CPU usage tracker. So here's what interfacing with Deephaven and Go looks like right now. So we can create a new input table that we're going to stream table to. We just specify the schema, and then we just call new append only input table from schema, and there's our table. Then what the other thing we're going to do is we're going to build a query using the data that we're going to be streaming in. And this whole thing is one very large query. So the Go API can build queries of arbitrary size. You can have as of joins. You can have just updates, drop columns, tail, whatever you want. It all works. And you'll notice that all of these, even though it's several different tables and several different parts of the same table being done separately, it can all be done as a single query and thus a single request to the server. Then the last thing we're going to do here in the code, actually second to last thing, is we're going to bind all these tables to variables so that we can see them in the web UI. And then we're going to upload some CPU usage data just from the local computer. And we're going to add it to our input table. And then our input table is slowly going to grow in size and get all of this data. And we can use the web UI to do some visualization. So it's running right now. And here's the web UI. So at the bottom here, we have my actual CPU counter. Here we have the table, and the right column is the CPU utilization in percentage. So we're hovering at around 25-ish, 30% right here. And you can see that this graph down here of CPU utilization roughly matches up with the actual graph right here. So let's build some software project to get our CPU spinning up fast. And as you can see, our CPU usage suddenly spikes because we're doing something, and that is immediately reflected in the Deephaven graph right here. And it tracks pretty well with the local graph right here. It is averaged over a slightly longer period of time, so it'll look different. And it's for all cores, not just each individual one. But as you can see, it tracks it very well. So the Go API can do streaming. You can do table operations, manipulate them however you want. And then you can use the full power of Deephaven to make pretty visualizations.
All right, and today I'll be presenting some stuff for the using the OpenDOTA API, which is a publicly available REST API. This is something I've been working on kind of in the background for a few weeks, and this week it has it took precedence. So I've spent quite a bit of time on it this week, and I'm pretty happy with the results. So I've packaged a lot of this stuff up on in a Deephaven examples repository, and I look to advertise that some more soon. And I'm putting the finishing touches on it. And so the OpenDOTA API, for anybody who doesn't know, Dota 2 is a very popular video game at the moment. It falls into the MOBA category, or multiplayer online battle arena, which is a very popular category of games, in particular for professional gaming or esports. And so Dota 2 happens to be actually the most lucrative and one of the most popular, if not the most popular, MOBA at the moment. I believe last year's big tournament, which they call the International, had a prize pool of well over $40 million. And this year, I believe it has already reached a prize pool of 40 million and is continuing to grow. So Dota 2 is not only wildly popular, but it was built out of a mod for an old video game called Warcraft 3. And as such, many parts of the game are accessible to developers. And so what is pretty cool is that a bunch of developers got together and created the OpenDOTA API, which takes data from replay files and actually from live games going on and makes them publicly available to anybody who wants to check them out. And with this API, you don't need an API key, and you can do up to 60 API calls a minute or up to 50,000 a month. If you want more, you can get an API key, and the pricing is very reasonable. So in the Deephaven examples repository, there are 6 scripts that get run by app mode that set up a bunch of utilities for some data, some constant data that doesn't change very often. These are collected into a class called Dota 2. So I have in memory right now a class called Dota 2. So if I print out a list, I can see 4 different attributes. Each one of these is a subclass of this, which has, and each subclass has 3 attributes. It has an attribute called JSON, which contains the raw JSON data. It has a data frame, and it has a table. So let's say I'm interested in what heroes I could currently pick from, as well as their attributes. I can set that equal to a table, and you'll see it pop up in the bottom right corner of the screen. And so right now, this is a Deephaven table of all of the heroes in the game, their hero ID, their names, their roles, their attributes, and some other things about them. There are other ones here. For instance, there is an items. You can get information on all the items available in the game. One thing that they have data on for every single match is the chat. And so Dota has a large number of chat wheel options available. So if I want to look at the chat wheel options, all I have to do is access the table here, and it will pop up in the bottom right corner of the screen. This has, I believe, like 1,503 currently available chat wheel options. Each has an ID. And so there are 2, there's one script that comes with the repository itself called Get Live Matches. What this will do is it will get a table, or 2 tables rather, of the top currently ongoing matches right now. And so this updates once a minute for an hour, and you can change that if you'd like, but you can see a whole ton of information here about each of these top currently ongoing or recently having, if they just recently ended. And the top ones are determined usually by MMR, or the average matchmaking rating of the players involved. So if you're interested in taking a look at one match in particular and learning a whole lot more about it, one of the scripts that runs via app mode defines all of the utilities and the functions to get all of the information about a match that you could possibly want. and that function is called get Dota 2 match. So I have a match that I've been kind of looking at here and playing around with this past week. All you have to do is give it an integer match ID. So if you're taking a look at the top live ongoing games, just take the match ID from the column that you're interested in and feed it to this function. I'll run this, and it takes about that was quick. Usually it takes 2 to 5 seconds to pull all the match data, but there is just an absolute ton of it. So let's take a look at the sum match class that I just created. It's got 6 different attributes, 2 of which are subclasses. Those are the details and the players. But you can see here there's 6 in total, including team fight information, chat information, and the draft information. The chat and the draft are Deephaven tables by default. So if I run this next, I now have the chat table, which has the timestamp of every chat, the player that said it, as well as the contents. And so I pointed out earlier that there are chat wheel options. They each have an ID. So most of the time in Dota, players use the chat wheel to speak to one another. So you can cross-reference this contents column with the chat wheel table. And I do plan on expanding over the course of time, expanding usage a little bit where it will automatically cross-reference the contents with this chat wheel. Up next is the draft. So there are a few different game modes in this game. Most of them include a draft where people will pick whether they will pick the characters that they want to play. And also they will ban certain characters. So you can see here is pick as false. That means these particular heroes were banned. There's timers in this particular game mode. So you get the time that's from the extra time they have, the time that it took to pick or ban these heroes, and so on and so forth. Next up is the players. There is just so much information packaged up in the players that I had to make a class in and of itself. Every single one of these attributes of this class contains information about each player, their performance, whether or not they're alive, how they did, information about their accounts, if it's publicly available, and things like that. Up next, we have details, which just is overall game state information. Things like, what buildings are still alive, what's each team's score, how long has the game been going on for, is it still happening, things like that. And then last but not least is the team fight information, which is really, really cool. This particular game had 5 team fights, and the first one, there's a nested dictionary here, which has the timestamp for the start and the end, as well as all the deaths that occurred, where they occurred, when they occurred, abilities that were cast, and just a whole bunch more information. So some of these things are still a little raw, and I'm putting the final touches on it. But the OpenDOTA API is really cool, but also for games that aren't complete, instead of these fields that you see being empty, they just don't exist. So I've tried to be as I try to cover all of my bases there, and so I've tried to make this very robust in that if the game is not finished and items are missing, that it will be obvious when you use this function to get all this information. So that's my presentation for today, or my demo.
That's it for this week. Thanks, everyone. Bye.